So if you want to take a minute and talk about GIS and planning.
Yeah, sure. So this, Rose mentioned earlier, this is what we call a nested site. It lives within the Appalachian LCC's main website, planning portal. So essentially, this is the GIS and planning nested site, and we'll go through one tab in that nested site, which is the GIS tools. So these are specific kind of use case tools inside of that. So basically, we have a little bit of information here about how to get data, how to request it, and also links directly into the conservation design and the other tools, the decision support tools that we'll talk about. So there's a list of data sets here and how to get data access, that kind of stuff. But one of the new things that we've been working on that's about to have a full rollout here is TNC's energy build out that the AppLCC funded, and that viewer lives inside of our GIS nested site here. I'll man this, and so we basically get to that from GIS tools and decision support tools, and there's some database links, the national map, just places to get data. But we can go to energy build out here and see a viewer that I'll introduce to everyone with that energy data. But for the sake of this demo, I might show you a slightly different version of this because it's easier to view for demo purposes. 1 second. This layout's a little better for demoing. So, like I said, this is the project that TNC is just finishing up, and it's basically projecting gas, wind, and coal development into 2030. And so I'll show you guys kind of how this viewer works. So if we want to look at some of the raw models that were developed, we can go up here to energy data, and we'll look at coal, for example. And this is just a binary kind of model for coal that's projected at greater than 90% probability of development, which is green, or less than 90% development is green, and the black is greater than 90% probability of development. So we've got this kind of raw data for wind and similar kind of viewers. One of the interesting, and gas as well, of course. So one of the interesting things about this viewer that makes it kind of handy is that we can overlay simple things and change the opacity right here. So that's, if you want to look at the raw model output, that's what this kind of tab does. But I think a lot of the utility is found in this energy impact analysis tab. So if we open up this top tab here, resources, you can just click a couple of kind of background data sets that you might want to just look at. But if we open up the energy analysis, we have kind of a terrestrial approach to how energy is projected to impact forest cores and or watersheds. I suppose that this particular group would be interested in looking at one of these overlays in particular, which is the brook trout overlay. So if we want to have a look at intact sub-watersheds here for brook trout, where they're predicted at the highest levels of energy development. So these are a cumulative energy development risk, so both or all three, coal, gas, and wind. And so this is just a simple overlay of these sub-watersheds where there's a greater than 90% chance of energy development inside of the watershed. And those areas are blue, and this only deals with intact and reduced subs inside of the geography. So you can kind of scroll around and look at those. The map tools up here will help you move around inside of this viewer. And you can easily print a map to a PDF or a JPEG by clicking this little print icon right here. So some of the other aquatic kind of based overlays here, we can divvy it up by individual energy development type. So wind, and it's kind of in these categorical status here of high to low risk. You can do that for each individual type of energy development. And also some more interesting overlays like, let's see, important drinking water from EPA data. So basically this is a measure of how important a watershed is to drinking water. You can do those kind of simple overlays. The terrestrial overlays may not be as interesting to this crowd, but you can view similar things. So individual energy type, so wind energy to forest cores, or gas or coal, or you can look at all of them combined. So one other kind of interesting feature here of this viewer is the inclusion of partner data, that folks that have shared data with us. So a few of these are aquatic, but most of them are terrestrial. So we want to look at the risk of energy to cerulean warbler priority areas, something like that. We can look at the priority areas and then turn on the risk. So we've got multiple data sets from partners looking at everything from warbler priority areas here to, if you look at the Ohio Fish Habitat Partnership, fish and mussel priority watersheds. You just, again, you're getting an overlay of multiple types of energy development sources here and the risk for those sources. So if you don't like this kind of background, this is something Matthew was showing earlier. You've got a couple of different options if you want to see satellite imagery, or if you want to see your kind of state boundaries to help you navigate where you are. And again, you can kind of do this to help you find out where you are. Turn on the opacity and alter that. And that's about it.
Can you search that via an address?
Sure, yeah. So if we've been using Shepherdstown, why not? We're in Shepherdstown now. If we go back and turn on something that might be applicable in Shepherdstown, let's see. Let's look at forest cores. So we've got this kind of no risk areas to forest cores around Shepherdstown, particularly, and then the screen turns blue. So these are, we can just kind of scroll around inside of here. Looks like there's some low risk to this forest core for energy development, and that's cumulative. We could divvy it up by individual development type as well. But yeah. Question? I don't think so. That's an interesting question. I'm sorry, Jane did.
Which it has a footprint. So the calculations of the model include the footprint. So total loss of canopy or watershed cover. So it is included in that sense. If your question is in a linear carriage from the source and the infrastructure, not entirely, except for those which are already there. So it is a balance between the two. And I think there's also the other issue. This is a build out of a 2030 time frame. and that the types of statistical analysis that were used in the model was a learning model, a bootstrap sort of thing, in which it used many variables to predict how that build out would occur. And so it's not just simply economic, et cetera. Proximity to transport is included in the predictive model. So it does have some balance of those sorts of things. And I think the other aspect about this that we talked about the session this morning was that all of that build-out data set you can download. So if you want to import it to another session or area, or you have more fine-tuned data, like you're talking about, that corridor delivery, that can be added to the user. So it's not just the model that's being delivered and the viewer, it's the data itself to be applied in that predictive, from now to 2030 timeframe.
These consultant products downloadable too? Is it just the input data to the model, or is it this output that's downloaded?
The outputs, of course, can be downloaded, but what we're implying as far as the energy footprint, that you can download those data and then reapply them to your own species-specific questions. But the model outputs or the images, showing that footprint for the forest and watershed, the primary impacts are there. If you're going to look at a species-specific potential impact, then you will have to add your own species-specific or habitat type or whatever you want to look at, and then do, as an expert, your interpretation of that. So the model information is available to you. They don't, so it's downloadable from that, and that's one of the things that, when are we rolling this out? The end of the month? Something like that. Yeah. So final deliverable is due the end of this month, and again, it'll be on the portal and accessible to all that. We will be asking for the users that are requesting the data, for some information, because some of the partners have made their data sets, major bird blocks, et cetera, accessible to this platform, and so I think I forget if it was Jason that asked that question about tracking who's asking for the data. So when the partners are willing to release it, we're also willing to try to help characterize how it's being used.
You want to talk about the integration?
Yeah, that was a really good point, Gene. I think at some point in the very near future, one of the kind of real utilities to get at Callie's question is being able to use this as a decision support tool, and to some degree with your species-specific questions. I mean, the model itself and the output itself has limitations that you should understand in that context, and the spatial resolution of those predictions and all that kind of thing. But for brook trout specifically, if you get your catchment level data finalized and approved, it'd be pretty interesting to look at some of those in relation to especially some of this gas development that's going on up in here. Any more questions?
The question was the extent of our geography for our grant went to our boundary itself. Much of that was more so because of the energy impact. The shale formation and the Utica formation was kind of germane, but obviously, wind or coastal are entirely different things. So we might ask Andrew if he's got any interest in that, but that's why.
Major driver in terms of the coal and natural gas, we didn't consider it at this point, but we could certainly consider it for eventually.
So again, that's just one stressor, but because we support the whole eastern brook trout in its entirety, Even though that's energy, the idea of other stressors impacting your resource is, still being included in this platform. So that was just that particular grant, and it can be expanded or other stressors brought in. So again, a lot of the climate model work, you will have those data as well as other some collaborative work that's being funded through either the Northeast Climate Science Center or the Southeast Climate Center or even USGS, the regional offices. So any of that stuff we bring together and bring it to your resource. So.
If I could ask that, so something along those lines for us in the Northeast with wind, like you had mentioned, how does that data get incorporated into this? Is that something that you do, or how does that work?
So this is a predictive model. The model program, the source code used for that is accessible, and the predictions, obviously within our geography, are accessible. So the issue is if you want to extend that for any of those, wind or modestly cold, but anyhow, if you want to extend that for the wind, you can have the program itself. You can take your resource, geospatial information. You can run the same model with that other extent. So we funded the intellectual capital to create the model, and then you have the access and you can apply it wherever you choose to whatever resource you want. And obviously it then becomes your expertise to do the proper analysis and presentation. So again, the time frames are kind of fixed just because of the limitations of the assumptions that went into the model. So that's why our time frame only goes for that. We thought that was a reasonable time. But you can use the programming codes are openly available, and again, downloadable from our site.
Perfect. Yeah.
Say goodbye.
Yeah, and just to follow up on Diane's point, I think maybe you were asking something slightly different, that how at least I interpreted it, is that could you just do a simple, if we just put up a few models in our viewer that's not in this viewer, so if we just put up the raw model of wind at 90% or something, could you just look at catchments on top of that or something like that? I don't know if that's what you were asking.
Well, both. I mean, that was the initial thing that I whispered in your ear was this. But then now I'm thinking, this only goes to New York, and I know that for New Hampshire in particular, there's a lot of drive for wind development.
Sure.
And so obviously that's a concern because they're mowing down treetops. So the idea would be that those mountain populations are obviously in the way.
risk,
So, so both.
Okay.
It was both.
Great. Thanks, everyone.
Any other questions on the energy build-out?
And we could do that, though, to answer, to finish your question that I whispered, right? That you have the layer here, and then we could easily overlay the catchment data or HUC data or
Right.
whatever.
Yeah, it's
on
not
top
built
of that.
into that tool, but
Right.
the underlying model output can easily be put into a different, just the general conservation design that Matthew was showing everyone earlier.
Yeah, that symmetry.
I guess I just wanted to add one more, which I had forgotten, and I said we had other data sets in the urban expansion model. The urban expansion model is another part of the data sets that will be coming in. So there are models that are looking at that footprint, and obviously that's something that's very important, in future projections as well. So that was funded through the Southeast, and so at the culmination of that study, that data set will be available as well.